Hello everyone, let's look at reverse integer. We are given a 32-bit signed integer. We need to reverse digits of this integer. And also, this 32-bit signed integer has a range, so we need to return 0 when the reverse integer overflows. For the first example, the input is 1, 2, 3, so the output is 3, 2, 1, the reverse value. The second example, the input is negative 1, 2, 3. The output is also a negative value. That's negative 3, 2, 1. Looking at the problem, one easy and straightforward solution is to leverage the built-in array functions. So we can convert the input integer into a string, and we split that into an array. Then we reverse the array, then we join them back, and then convert that back into an integer. And then we do some limit check, then we can return the result. Let's look at the code implementation. First, let's get the sign for the input. The sign value will either be positive 1 or negative 1. Then let's do the conversion. Let's first get the absolute value for the input number, and then we convert this integer into a string. And then let's split the string and change that into an array. And then we use the array built-in method reverse to reverse the element inside the array. Finally, let's join it back into a string. So far, we have the reversed string value. Before we return, we need to convert it back to the integer and apply the sign. So, let's multiply this value with our sign to get back the result. But before we return the result, we need to check the limit for the input. So if the reverse integer exceeds the limit for the negative and positive value, we need to return 0. So what is our limit? So for a 32-bit signed integer, the limit is 2 to the power of 31. This is our limit, and if the result exceeds this limit, then we simply return 0. Otherwise, we can return the result. Let's submit. It passed. Let's look at the complexity. For the space, it's pretty straightforward. It's constant. We only claim a couple of variables. But for the time consumption is on the array reverse. The built-in array reverse will loop through the array, and the time complexity depends on length of the array. So, the total time complexity depends on how many digits does this input number have. So, for the time complexity, the result will be O of log 10 of x. But if we are not allowed to use the built-in reverse method, how should we solve the problem? I think one solution is to have a while loop. In each iteration, we pop the last digit by running modular operation, then push the last digit in a result and update this result. Let's look at the code implementation. So we can keep getting the sign and check the limit. In the middle, let's have our result. In the while loop, the termination condition is x, input x is not 0. And inside the while loop, every time we do a modulo result, that's x modulo 10. And this result will be added into result. So this is how we push the last digit into the new record. And then we need to update our x. If the sign is greater than 0, we use mass.floor. Otherwise, we use mass.cell. By doing this, we can keep updating x and result. And then we do the same limit check, and then we return the result. Let's submit. We have this error. This is because I have a typo here. Let's submit again. This time, it passed. And we can see, for this while loop, the space and time complexity should not change. So the space complexity should still be a constant, and the time is still proportional to log 10 of input x for this while loop. Thank you for watching.